The first type of graph that we're going to look at for quadratic functions uses vertex form to help us graph. Vertex form is what we're used to seeing from yesterday, and it looks like y equals a times the quantity x minus h squared plus k. We're going to skip down to vertex. Now the original parabola, the parent function, has a vertex at 0, 0. But h and k move this graph side to side and up and down, which takes that vertex from 0, 0 and moves it left or right and moves it up or down. So however much it moves left or right, that will be the x value of your vertex. However much this graph moves up or down, that will be the y value of your vertex. Now keep in mind, inside the parentheses is backwards, so if it says plus, that means the graph has moved to the left, and if it says minus, that means the graph has moved to the right. So you're pretty much going to take the opposite of whatever is in the parentheses, but then keep the number after the parentheses the same. The axis of symmetry is a vertical symmetry line at x equals h. The x value of the vertex is the axis of symmetry because the symmetry line has to go through that vertex. We are going to use the abbreviation AOS for axis of symmetry. The Y-intercept is where the graph crosses the y-axis, and it can be found at 0, something. So plug in x equals 0 and see what you get for a y value, and that is your y-intercept. We're going to talk about x-intercepts a lot. On the ACT practice, you may have seen a problem or two that asked, what are the zeros of the function? The zeros of the function are the same thing as the x-intercepts. So x-intercepts use three names. The x-intercepts, the solutions, or the zeros. All of those words mean the x-intercept, and it is where the graph crosses the x-axis. Okay, our first graph unfortunately has not moved at all. The vertex here is 0, 0. So to graph this, to get a good picture of the parent function, so you may want to write here that this is called the parent function. We are going to pick some points and plug them in. I'm going to pick -2, -1, 0, 1, and 2. So plug in -2. What is -2 squared? 4. What is -1 squared? 1. What is 0 squared? 0. 1 squared is 1. And 2 squared is 4. We need to plot those points to see our parabola. So take a moment, plot those points. Remember that a parabola is a U shape, so when you connect these dots, make sure you try to connect them in a smooth U shape. Try not to make a V point at the bottom. I've seen some pretty awful looking parabolas in my day. Try to make it look like the U that it should be. Also remember to put arrows at the top indicating that your graph will continue going on in that upward direction. All right, domain and range. We need to talk about domain and range. Oh my goodness. The domain refers to the x values and the range refers to the y values. The x values are the independent variable. we can plug anything we want into this function. There are no limitations. There are no numbers that we can't square. Here's an example of a function that has limitations. The square root of x. Can you put negative numbers under a square root? You can't do the square root of -4. It's not possible. So the domain of that function would be restricted because you can't plug negative numbers into it. But x squared, we can plug anything we want. We can plug huge positive numbers in. We can plug massively negative numbers in. It doesn't matter. So our domain is all real numbers. And remember that the capital R with a double stem is a symbol representing the word real numbers. Words, real numbers. The range represents the dependent variable. The y values depend on the x values. And what I want you to notice here is our vertex has a y value of 0. These next points have a y value of 1, and then a y value of 2, 3, 4. All of these points are above 0 on that y number line. So all of our y values are greater than or equal to 0. When you square something, it makes it positive. So all of those y values have to be 0 or larger. Okay, let's look at B. And I'm going to try to write out step-by-step instructions representing what I'm doing. Okay, so step 1, we're going to identify our vertex. So we're going to look at this function and think about the vertex started at 0, 0, but now something's happening in here. There's a +6 in the parentheses and there's a -2 outside of the parentheses. How did the vertex move? The +6 indicates that the vertex moved which direction? Left 6. So our vertex is going to be -6. And what does the -2 indicate? Down 2. So our vertex is at -6, -2. That vertex is going to move left 6 and down 2. Nope, you don't have to. You just identify the vertex. You don't have to plug anything in yet. Just identify the vertex, put that on the graph. You've just saved yourself a whole bunch of math. Step 2, I like to sketch in the axis of symmetry. The axis of symmetry goes through the vertex, so it is on the line x equals -6. So I'm going to use a dashed line to indicate where my symmetry line is. Step 3 is to pick an x value close to the axis of symmetry. If your vertex is close to the y-axis, you can pick 0. This is 6 units away from the y-axis, so picking 0 is probably not going to help us. It's best to pick an x value about 2 units away from the axis of symmetry. So if this axis of symmetry is -6, let's go 2 units back toward the middle. This would be an x value of -4. And we're going to plug that number in and figure out what point, where would that point be on that line. So let's plug in -4. You can do this using mental math. You can write it out and follow PEMDAS. But the best method is to pull out your calculator and do parentheses, -4 plus 6, close your parentheses, squared, -2. Let your calculator do all of the math for you. I'm going to show my work down below. We're doing -4 plus 6 squared minus 2. That would be 2 squared minus 2, which is 4 minus 2, which is 2. So I plugged -4 in, and I got 2. This is a point on our parabola. So on my graph, I am now going to plot the point -4, 2. There's a reason I put the symmetry line on the graph. If this point, -4, 2, is on the parabola, there's another point on the other side of the symmetry line. So this point is 2 units away from the symmetry line. I am going to go 2 units in the other direction, and there's another point on my parabola. So really, you only have to plug one number into this function to get one point on your parabola and then reflect that point over. And now we have enough information that we can sketch in our parabola. The domain is all real numbers. Now, the range for the parent function was y is greater than or equal to 0. But we moved this graph down 2. So notice our vertex has a y value of -2, and then all of these other y values are above -2. So, where's my pen? Oh my goodness. Our range is y is greater than or equal to -2. If you are a highlighter person, I would strongly suggest that you highlight the -2 in the equation and that the range is y is greater than or equal to -2. The range is affected by up and down movement. So if we move the whole graph down 2, we are moving the range down 2 as well. First, identify your vertex. What is the vertex for this particular graph? -2, -7. +2 indicates left 2, -7 indicates down 7. So our vertex is -2, -7. So let's plot that point. Because this is pretty close to the y-axis, I'm going to pick 0 and plug in 0. So plug in 0, see what you get, reflect that point over. We plugged in 0, we got a y value of 5. Plot that point, reflect that point, connect your parabola. Your domain is all real numbers. Who wants to be brave and tell me what the range is? Give this one a try on your own. Okay, this time our vertex is +2, +3. -2 indicates +2, and +3 indicates up 3. So 2, 3 is our vertex. And that means we've got an axis of symmetry at x equals 2. I'm going to pick an x value close to my axis of symmetry. I'm going to pick 0 and plug it in to see what point I get. I got the point 0, -1, which happens to be my y-intercept and a point on the parabola. I reflect that point to the other side of the symmetry line and then sketch in my parabola. What you might notice is this parabola opens downward because there's a negative in front of it. My domain is all real numbers. The range. I know that this graph moved up 3, so I know the number is going to be 3, but because the graph flipped, all of those y values are not bigger than 3. Those y values are now less than or equal to 3. So at the bottom of your paper, it would be probably beneficial to write, if your graph opens up, your range is y is greater than or equal to something, and that something is how much the graph moves up or down. If your graph opens down, if it's a hill shape instead of a U shape, your range is going to be y is less than or equal to something. And that something is the vertical translation. Up 3, that number is going to be 3. Down 5, that number is going to be -5.